Hi, this is Suchit Mahajan. I'm a student of knowledge engineering at Pulchowk campus, and today I'm going to present on ontology. So this is a slide from our professor Aman Sakya. So let's get started. Ontology. So ontology is a term that dates uh, that origins from uh, Greek word logy and onto, right? So the term is borrowed from philosophy, where an ontology is a systematic account of existence. So to make this to speak in general words, so an ontology is an explicit specification of conceptualization. So, how does the uh, concept relate to each other, right? So, a conceptualization refers to an abstract model of some phenomena in this world which identifies a relevant concept of phenomena. So, explicit means that that the type of the concept used and the constraint on their use are explicitly defined. So, uh, for example, if we if we like model the family tree, we can based just on uh, genetic linkage, right? We can say that uh, uh, a father and a mother, a person has a unique uh, has father and mother, and father needs to be male and mother needs to be female, and there can only be one father and one mother, right? uh, we can also say that the father and mother couple can have multiple children, and multiple children can be a male or a female. So this kind of relationship, right, can be explicitly defined or conceptualized, needs to be explicitly conceptualized in ontology. So let's define. Uh, so an ontology is a logical theory accounting for the intrinsic meaning of a formal vocabulary. So uh, during this process, right, what do we do is we specify uh, the actual word or the vocabulary that we are going to use for to explicitly represent some concept, right? And we stick with them. We also define uh, what those what uh, the relationship between the two concepts and uh, and not only that, we define facets or the number uh, of such relationship that can occur as well, right? So this is that's what H in the ontology. And ontology is a formal definition of a body of knowledge. Um, an ontology is a catalog of type of things that are assumed to exist in a domain of interest T from the perspective of person who uses a language L for the purpose of talking about D. So, and before it was like for the representation of uh, knowledge, but in here we go to detail. An ontology is a catalog of type of things that are assumed to exist in domain of interest D. So we when we develop an ontology for interest domain of interest D, We list all the terms or the concepts that is used in that domain, and uh, so we like create a language, uh, and language for the purpose of talking about that thing. So that is ontology. And ontology is a shared understanding of some domain of interest. So uh, this is the definition that's given. uh, and ontology is so the general feature of ontology is we draw from all of this definition, right? And an ontology, a given field or domain of interest. It has ontology is defined for a given field or domain of interest. So within the boundaries of such things, right? Such thing, some concepts are assumed to be exist, right? And uh, so we want to like communicate things about communicate uh, about those things that exist in that domain of interest, right? So it's not only that, the thing is this is in a formalized explicit and semantically consistent way. You want a formalized and explicit static and semantic consistent way of us talking about those things, right? So that's what ontology gives. And ontology is the explicit description of a domain. So what does it has to be explicit? We need to have concept. We have to know the properties and attributes of constraint on properties and attributes and individuals, or the thing that are an example of those concepts, or an instance of those concepts. An ontology defines has two parts, a common vocabulary and a shared understanding, right? So ontology is a shared conceptualization of a domain, and ontology is a set of definitions in a formal language for terms describing the world. So an ontology provides a shared and common understanding of a domain that can be communicated between people and heterogeneous system. So it's an explicit description of a domain, right? So um, share in some uh, uh, common common structure, right? Common definition is no formal language for this. Okay, so let's see an example of ontology, ontology. So uh, we have this ontology have a concept of environment, uh, event, agent, uh, and date time, right? So activity, can we can say that it occurs in some environment, and uh, in that activity we can have some event, and that event is either performed by some agent, and there are other resources um, about the event. And one of the most um important important information about event is when it occurs. So it has timestamp property, and also other activity can be activity will have like the start time and the end time properties. So one of the simplest of user ontology is travel ontology, which is this is an example ontology that's given. So you can say that thing is an activity. An activity could be adventure, sightseeing, relaxation, and in adventure it could be bungee jumping, safari, In sightseeing, it could be we could go for safari sightseeing, or we could go for museum, but museum would be an adventure activity, or we can go for relaxation activity like yoga, sunbathing, right? um, so other thing could be like accommodation rating could be a thing. So accommodation could be another thing, right? So uh, it could be accommodation, we could get an accommodation in bed and breakfast, we could go to hotel, and hotel could be a luxury hotel, or we can just um, camp in campground, right? So other thing could be like destination. So the destination could be of a retiree destination, or budget hostel, a hotel destination, backpackers destination, or it could be a rural area, it could be a quiet destination, it could be a beach, it could be an urban area. So destination could be a rural area, could be a farmland or a national park. Also, we may need contact, which is a kind of thing, right? So these are like this is like a thing, uh, all the concepts that we need to know when we need to like travel, I guess. So types of ontology. So there are we could classify ontology in to based on various aspects. So one of them could be upper ontology and domain ontology. So upper ontology is a common ontology throughout all domains, right? Uh, so this is a top level ontology that defines kind of like a meta knowledge, while domain ontology is used defines a specific domain only, and it is used to uh, communicate information or knowledge about the specific domain only, or it could be an object ontology or task ontology. Object ontology is an ontology on things, right? So things or events. So it could be like classification of animals, classification of birds, right? Classification of plants. So we are talking about some kind of object. While in tax ontology, we will be talking about how do we do a specific thing. So tax ontology and ontology on how we can do something. So we can also differentiate ontology on heavyweight ontology versus lightweight ontology. So for heavyweight ontology, uh, it's uh, it's fully described ontology, or a big ontology including concept, definition, and relations, in particularly in logical way. So it's heavyweight will have a loss of relation, right? Concept definition, while lightweight is a partially described ontology, including typically only is a relation, right? So in in heavyweight ontology, there are lots of properties, right? Properties, but properties and relations, while lightweight ontology is just concepts that are linked with each other relationship. Uh, so Example of lightweight ontology could be taxonomy or treasures, right? So, so this word has this meaning. This has these words which have similar meaning. So domain ontologies. So we have a lot of examples predefined ontologies that has been that are public and free to use, right? For example, we have Unified Medical Language System (UMLS), opened by medical ontologies, gene ontology for genomics, plant ontology for plant structure and growth development stages, etc. CDOC-CRM, conceptual reference model, and ontology for cultural heritage information. Right? So those are the examples of ontology, right? So moving further on this, so medical domain have cancer ontology from National Cancer Institute in United States, right? So a cultural domain has art and architecture treasures, AAT with 1,25,000 terms or 125,000 terms in the cultural domain. So union list of artists, ULAN with 220,000 entries on artists, right? So icon class vocabulary had 28,000 terms for describing cultural images. Geographical domain has 80 treasures of geographic name containing over 1 million entries. This is, so there are three approaches for defining a top level ontology, like a formal approach. We use a logical formalization, right? Uh, we define something logically. So, it's like fully abstract. It's um, advantage is clean, right? It um, can be easily interpreted by the computer, right? But the disadvantage is it's hardly understandable by people. Uh, so example would be SOAS top level ontology and Dulce. So linguistic approach used an extension of linguistic concept, right? It's partially abstract and it's partially general. Uh, so this is like easy to understand for human as well, but the disadvantage is uh, it is limited to the linguistic world, and unlike informal which uses logic, we can't really detect anomalies from linguistic approach. So there is another thought that is pragmatic approach. So so in this we use an extension of this is a use an extension of everyday concept, right? So it's mostly genderable, prose, understandable and applicable to all the world. uh, but the disadvantage is there is a lack of solid foundation. Example: Sumo, OpenPsych, and EDR. So linguistic top level ontology could be a lexicon, thesaurus, dictionary, are close to ontology. So there are plenty of concepts and their relations, but there is a lack of formal system. So difference between linguistic knowledge and object knowledge. Linguistic knowledge could be like grammar and categories. Right? So Linguistic knowledge can be used to define grammar and categories, while object knowledge has the knowledge about the target ontology, right? And these two type of knowledge are dependent to each other. We need to use grammar for communicating, right? So we may use categories. That's in the linguistic knowledge to define an object or categorize an object, right? So those two knowledge can depend on each other. So one of the lexical linguistic type-level ontology is wordnet. So what does wordnet had is it has it electronically links word to its meaning. It's an open source kind of dictionary. So um, so that is one type of linguistic type-level. So there is also concepts which have one of since it is so one of the uh, the source which has 79,689 nouns and 13,508 verbs. So we have uh, we have relationships like synonym, hypernym, hypernym, holonym, or meronym. So main stages in ontology development, right? So most of the time the ontology may be available, but sometimes we need to uh, create our own ontology. The ontology creating process is not linear. It it's like a iterative process. So first of all, we need to uh, determine the scope of our ontology. We need to consider about reuse. So we can use various knowledge extraction technique to enumerate terms. We need to uh, the, define the taxonomies or the terms that we are going to use, and we need to define or properties that it holds, and we need to define the facets of the relationship of within those concept, the domain and range of the uh, properties, and we need to define instances of this concept, and we need to check for any anomalies in our ontology. We need to then further revise this if we find any anomalies on the system. So determining scope, right? There is no correct ontology of a specific domain, right? So an ontology is an abstraction of a particular domain, and there are always viable alternatives. So we can't since this is a language, and ontology of one language will be different from other. Not only that, but ontology created by one group can be different from ontology created by other group. So what is included in this abstraction should be determined by uh, the the use to which the ontology will be put. Why we are actually developing this ontology, and the future extension that are already anticipated. So we need to consider how will this ontology be put to use, uh, and how we plan or see how this ontology is extended in future. So basic questions to be answered at this stage would be, what is the domain that ontology will cover, for what we are going to use the ontology, what type of questions should the ontology provide answers to, right, and who will use and maintain this ontology. So next step of the process is we need to consider use. uh, so ontology will, if we want ontology of specific domain, we should first check if uh, the ontology for that domain is already available. So if it is available, it's better to use that, or try to use that or improve upon that uh, to fit your requirement, because uh, we will not just get the terms, but we can also get other software that may utilize data as per referring to the specific ontology. So if we have a STEAM standard, uh, then all the data, you can use the software or product uh, that interprets the data specified in specific ontology. So enumerate terms is, so in the knowledge acquisition process, right, we need to uh, write down in an unstructured list all the relevant terms that are expected to appear in that ontology. uh, so nouns from the basis for class name, pause from the basis of property names. So uh, traditional knowledge engineering tools, example laddering and grid analysis, can be used to obtain the set of terms and the initial structure of this term, the relationship that can be exhibited shown from this term. So taxonomy, it shows the relevant term must be organized in a taxonomic hierarchy. So opinions differ on whether it is more efficient or reliable to this in a top-down or a bottom-up fashion. So we need to, after the relevant tasks must be organized in taxonomic hierarchy, meaning that a word can define a specific type of something, right? So we should define this as and we should link all of them together, right? So this could be a challenge as well. So we need to define not only terminal define taxonomy, but we need to define properties as well. Um, so every terms that is used may have a specific property, where a specific property, and based on those property, maybe we may have defined it the taxonomic hierarchy as well. So whenever A is subclass of B, every property or statement that holds for instance of B must also apply to the instance of A. So based upon this rule, we have already like created taxonomy hierarchy. So it makes sense to attach property to the highest class in the hierarchy in which they apply, right? So based upon this, we can notify that which information will the organization need, right? Something like that. So we can also define facets. So what do we mean by facets? Is we could define that some kind of cardinality restriction. Like for example, a person can has only two parents, biological parents, one mother and one father. Mother is male and father is mother is female and father is male. So this kind of relationship can need to be defined uh, in your facets. So not only that, we need to fill ontology with such instance is a separate set, right? So number of instances should be greater than the number of classes because classes are a generalization. Thus, populating an ontology with instances is not done manually. It's also done retrieved from legacy data sources. So it's extracted automatically from a text corpus as well. So last step is we need to check for incompatible domain range definition for transitive symmetric or inverse properties, cardinality properties, and requirement on properties. Such property value can create conflict with domain and range restriction, right? So we need to check for anomalies. So if there is anomaly, we need to revisit, right? So uh, so we although all the process of ontology acquisition is cannot be automated, uh, since the manual ontology acquisition remains a consuming, expensive, and highly skilled and sometimes cumbersome task. It's You can leverage machine learning techniques uh, for knowledge acquisition or extraction or knowledge revision or maintenance to uh, leave those manual burden and try to generate ontologies semi automatically. Thank you.